Lesson 2, we will continue to study hypothesis testing to compare two sample average. Previously in 9.1, when we are given sigma, is that right? We are using Z formula, right? We learned that before. In reality, we know that that's not the case because we usually sigma it should not be given, right? So in other words, in reality, most of the time, we will be given the sample standard deviation, S1, S2. So in that case, we cannot use the previous formula, that Z formula, right? We have to use something similar to our previous like T formula, if you remember, right? For the one sample case, we have this T formula here, right? And then for the two sample case, this T formula is very similar. We have S1 squared previously, sigma 1 squared divided by N1, now S1 squared divided by N1, right? Plus S2 squared divided by N2, right? It's very, very similar. Let's use some examples here to help us understand, right? How do we apply them? Say we want to compare those two counties, the average size of the farm. From Riverside County, we randomly select how many farms? 8 farms, okay? We find out the average size of those 8 farms, 191 acres, right? The sample standard deviation, 38. And then from another county, San Diego County here, we have a sample size, 10. 10 farms, average size of them, 199 acres, right? Sample standard deviation, 12. At alpha equal to 5%, that means 95% of confidence. Is that right? Can we say there is any significant difference in terms of the size of the farm for those two counties? Everybody? The question, I think, is pretty straightforward. Is that right? So what do we do? 5 steps. Step number 1, write down H0, H1. So H0 always equal. Here we are trying to compare those two average. So mu1 equal to mu2. H1 here, mu1 not equal to mu2 because they say significant different. So they did not say higher or lower. Number 2 and number 3, remember, usually we do the calculation first. Is that right? So in this case here, we can still do the calculation first. Let's just use the same order so you don't get confused, right? Here, I put the step 2, which is the previous step number 3 first, right? We can do that because those 2 steps, they are independent. If we are using T formula, you can do either one first. It doesn't matter. But if it's a Z test, then you cannot do that. You have to do the calculation first, then use the p-value, right? So this case here, let's still using the same order, right? Number 1, write down H0, H1. Number 2, do the calculation. Because we are given S, we are given the sample standard deviation, we have to use T formula. Now we plug all the numbers into this T formula here, we find out the test statistics, negative 0.57. That's somewhere here, right? Negative 0.57. That's pretty straightforward, right, everybody? And then we, step number 3, find out, everybody, is that a p-value or critical value, right? Remember, whenever you are dealing with T formula, T test, remind you, you have to use critical value. Because if you are using p-value, you will get a trouble, right? But if it's a Z formula, you have 2 choices. You can either use the critical value or the p-value. Either one is fine, right? Now, because here is a T formula here, we have to use critical value, right? So the question is, how do we find out a critical value? Everybody? Is from what? From the chart, from the table, right? Which table? Determined by which formula we are using. We are using T formula. In other words, we should use the corresponding t-table, right? This is the t-table we are talking about here, right? The one-page beautiful t-table. For this t-table here, first we have to decide, is that one tail or two tail, right? Based on each one here is two tail. So we know it's the second row here. What's alpha? Alpha is 5%. So second row, two tails, we are looking for 0.05, this column. Now, which row from this column we need to select, determined by degree of freedom, right? So what's the degree of freedom from this row here? We have, let's see, the degree of freedom formula. Previously, if we have a sample size n, then it's what? N minus 1. Now we are in big trouble. Because what? Because we have two sample size. We have n1 minus 1, n2 minus 1. Remember, we have the, let's see, where is that? We have 8 farms and 10 farms, right? n1 equal to 8, n2 equal to 10. So in that case, n1 minus 1, n2 minus 1. Which one we are going to use? Everybody, we are going to use the minimum one. So the statisticians, they have done a lot of research, find out if we are using the minimum one here, the test accuracy will be better. So that's the reason we are using a minimum one here. So we got to use 7. Now we go back to that t-table. The degree of freedom here is, so this column here, degree of freedom 7, right? Looking for this, what do you have? 2.365. Everybody, follow me here. That's what we call critical value, 2.365. Let's check. Yes, we have that here, 2.365. You see that we highlight, right? We said that we can just draw 2 lines here. Why do we have 2 lines? Because two-side test, two-tail test, right? So that is our critical value. Compare with the test value, negative 0.57. Everybody, that number is more close to the center, relatively speaking to this critical value, right? So in other words, the data is close to the center. What's the center? H0. The data is supporting HO. The data is not rejecting HO. In other words, the data is rejecting H1. What does that mean? H1 is not right. That means what? We cannot see the difference. In other words, they are equal. Essentially, we believe they are the same. There's no difference. At least from the evidence we got, we cannot clearly see the difference. It's not significant. You see that in the beginning? We mentioned the sample size 8, sample size 10, remember. That's relatively small compared with the magical number 30. Is that right? In other words, if you have an 80, 100 here, you plug the number again, most likely you are going to see some difference. Okay, so that's the case when we intuitively, you can feel that way. When you have these three small sample size, it's going to be difficult for you to see the difference. Okay, so that's what we say. We cannot see, there is not enough evidence to conclude that those two counties, they have a significant difference in terms of average, the size of the farm. That's for this example here, using the t-test. The one part here, one more time, degree of freedom. We have n1 minus 1, n2 minus 1. Which one we are going to use? We are going to use the minimum one. All right, the second part, remember, after the hypothesis, we always want to use the confidence interval to double check, right? Essentially, they are talking about the same stuff. So the confidence interval, previously, we have the Z formula, right? Now we have a T formula. Everybody? It's a long formula here, right? But I mean, You make sure you plug the numbers into the right position, punch the numbers, you got results, right? So previously we have a Z. Now everything is a T, right? So that's I think that's the big difference, right? Now, the question here is when we plug all the numbers, how do we find out this T alpha divided by 2? Everybody? This T alpha divided by 2, number one, which table we are looking for? We are looking for T table because that's the T notation here, right? The T table, the one-page T table, right? Now, what's the alpha we are given? We are talking about 5%, right? 5% here. So that means, remember, everybody, you can either looking for the bottom here, the confidence, 5% give us 95% of confidence. This column, right? That's one way because that's the confidence interval, right? That's the confidence interval from bottom, 95% in this row, this column here, we need to select some number from this column. That's one way. Another way we can check out is when we talk about the confidence interval, is essentially two tails. You see that, right? Two tails. Then, in other words, 5% from these two tails, that's the same one. Match corresponding 95%. You see that here? So either one is fine. Now we know both, right? We can use either the bottom confidence level or the top, one tail or two tail. As long as you understand the confidence interval is what? Two tails, right? So now we find out this 5%. What is the degree of freedom? Same. N1 minus 1, N2 minus 1. So that's 7, right? That's 2.365. Everybody, the same number we have used before, 2.365. If you pay attention, the previous critical value, plus or minus 2.365. All right, so we plugged all the numbers. Now we find out 95% of time, what's the range, the difference, right, between those two counties from -41 to +25, right? So where's 0, right? 0 is inside, everybody. So that's the trouble we have, right? Sometimes bigger than 0, sometimes less than 0, right? Can we say significantly different from 0? No, we cannot, right? We cannot really say that, right? Because sometimes less than 0, sometimes bigger than 0. That means what? That means we cannot really see the difference. So essentially, when they are equal, it's actually included that here, right? So what do we say? We have the conclusion say there's not enough evidence to say those two counties, they have a significant difference in terms of the size of the farm. Everybody follow me? So that's for this 9.2 here, using the two sample t-test for the hypothesis testing.